Here we go. Um, so, by way of review, we talked yesterday how the derivative of a to the x exponential is, oh, sorry, I was thinking of the other one. My bad. A to the x natural log of a. That'll come in handy. What about the derivative of log base a of x? 1 over x natural log of a. Now, in the interest of helping us in a second here, would you write just next to that the change of base formula? Log base a of x is the same as natural log of x over natural log of a. It can be shown, and I'll be happy to show you why that is if you like. But you can always change from a log of some funky base to a natural log by that virtue of that kind of thing, natural log of the argument over natural log of the base of the log. Are you with me? With that rewrite, it would be pretty easy to see why that would be. 1 over natural log of a is a constant, and natural log of x's derivative is 1 over x. So that's one way to see where that comes from, though not the only one. Keep that in mind, put that in the back of your mind, and come back to it in a second. So today we're talking about integrating those two ideas, and obviously they'll probably have to do with the derivative. So what do you reckon the antiderivative of 2 to the x is? Typically, when you do a derivative of an exponential, I would expect to see 2 to the x log of 2, right? Right? But I don't see 2 to the x log of 2, then I just see 2 to the x. So what do you think? Come on, give it a go. What do you think the answer is? 2 to the x over natural log of 2. That's exactly right. Okay. Now, if you were to check that, you could check that by taking the derivative. If we took the derivative of 2 to the x over natural log of 2, plus c obviously wouldn't matter, then the 1 over log 2 is a constant. What's the derivative of 2 to the x? 2 to the x log of 2. And so, yeah, that seems just right. Well, that's pretty much in keeping with the power rule. I mean, when we take a derivative by power rule, we multiply, and when we anti-differentiate, we divide. Well, the same goes here. When we take a derivative with exponentials, we multiply by the log of 2. When we take the antiderivative of an exponential, we divide by the log of 2. So generally speaking, you could say that the antiderivative of a to the x is
A to the x over the natural log of a.
a to the x over the natural log of a. Right? All right. The other one is not so intuitive. So this one, we use the derivative to get the antiderivative. And that actually made sense because the a to the x appears in the derivative. But if you look at the derivative of log base a, log base a is not really in the derivative. You see what I mean? And so this, don't really use this idea and try and get that going here. It won't help you. Instead, use that idea. Right? Log base a of x is equivalent to the natural log of x over the natural log of a. I'll get you started. Now, what's one thing you can do? Give me a soft.
Pull out the natural log of a.
Pull out the natural log of a. Sure. All right. Good stuff. All right. Now this is also a good test for you. Hi. How do you integrate natural log? Is it 1 over x? No, that's the derivative. How do you integrate natural log of x? What's the method?
Ultraviolet voodoo.
Ultraviolet voodoo. Now, if you recall it, then all the better. Does anybody just recall it, having done it once and really have a good memory? Okay, I guess not then. Here we go with ultraviolet voodoo. If we ultraviolet voodoo this bad boy, UV minus VDU. It's good that you remember ultraviolet voodoo. What's U?
Natural log.
natural log of x. I'm going to go over here. What's dv? dx. Remember, dx is a thing. It's not a nothing, it's a something. du is 1 over x dx, and v is x. Okay, with that substitution then, we have 1 over natural log of a still out front, and a big old set of parentheses or brackets. uv, x natural log of x, minus the antiderivative of, what's voodoo in the integral? X over x dx, yes. We all concur. Okay, so we get something like 1 over natural log of a, x natural log of x, minus x. Now, whether you put the plus c in the brackets or out here, it wouldn't matter, because either way it would be a constant. And so that's the idea. So integrating log base a is going to involve, if you are asked to show all the work, it really involves change of base and then ultraviolet voodoo. But generally speaking, we could say the antiderivative of log base a is 1 over natural log of a, x natural log of x minus x plus c, and this comes from ultraviolet voodoo, or IBP, integration by parts, if you will. Okay? Are you with me? All right. Moving on to the next idea here. These then use those ideas. Will you play around with these three? You can see how they can kind of be used in conjunction with other ideas we've talked about. And feel free to talk more with your math amigos. We'll go over them in a minute.
Go for it. If you want an explanation. You go for it. So, you're done. So I feel like the first one's just gonna be product rule. Okay, first one's gonna be product rule. So for one, yeah, it's kind of weird. So let me just hold this that way. So think of it going backwards. So if you take the derivative of that, you're gonna get, so you can flip 1 over and natural log of 2, right? And then you're just gonna get 2 dx. And then the derivative, and then you take these segments here. So what's gonna happen is you take the derivative of this answer, you pull out that, and then you get 2 dx, that's all you take to the stay. And then those two just cancel out. Kind of that makes sense. I'm gonna try this one. Oh, you wait, product rule is not. Product rule for animals. I gotta think again, Michael. You just make a substitution and make them all easy. That makes sense. That's all I do. That's literally all I do. I don't know where that can't figure it out. I'll see something. Oh boy, that's weird though. Ultraviolet voodoo hydrogen gases. It's just that, well, there's no balance, so that's that might be fun. So maybe try ultraviolet voodoo. Yo, Sydney, what are you trying? I'm asking politely. I need help. I'm not too sure. I feel like ultraviolet voodoo might be what you want to do, Michael. So U equals just do X. Yeah, let's see. No, do ultraviolet voodoo. U equals X, and then dV equals the 1 over X.
That work?
Ultraviolet voodoo. I mean, I haven't tried it yet, but like that seems like it should
Seems
work.
like the best way to go.
If you have the 1/2 to the X dx, you just learned what that was. So.
You tried that and it didn't go? So did you let x be the u? U is 1/2 x? No. You would let best u is log, which there isn't, inverse trig, which there isn't, polynomial. Polynomial is the next best u, so you would let u Exponentials usually bad.
Because remember how the lots are changed, so you can pick a log big.
Because then du is dx, and you should be maybe better. Let's see.
Equals 1/2 x over natural log of 1/2.
Oh, you took the derivative maybe instead of
I know all those numbers, but just not with the right direction.
Oh, okay.
Oh, I just let my
Now we're trying this. Equals x, d equals dx, d equals 1/2 x dx.
How'd you?
Equals what is d equal? 1/2.
You're doing the first one.
Natural log of 1/2.
Success?
Yeah, I'm not there yet, but I think had I done that.
Okay. Hopefully got you 2 times through with an exponential. You did a great
Violet minus ew, icky. Ah, the integral of 1/2 x over natural log of 1/2. That sounds gross.
That's a constant.
Oh, it is a constant. That makes it actually a lot easier. And then it's just basically
That one you just did.
yeah. So it's the same thing over again.
Let's see.
talk so bad.
Me?
Did I not make it clear?
You don't need to change it back to okay.
We do not.
This is the balance.
Right. So what do we got there? 6?
7 over L.
How we doing? Okay. Do the last one, and we'll move along.
Wait, how did you get 3?
The 7 minus 1 is 6 divided by 2.
Oh, that's right. 7 to the 0.
Yeah. Thank you for asking.
It's exponential, Michael.
So
The integral from 0 to 3 to the x.
first objective is to set the integral correctly. Then
Oh my goodness, it's a volume.
arithmetic rule to help you. Or use it. One integral will be sufficient.
Hopefully we can win this circle. He looks really good.
But look to use rules of arithmetic to make your life easy. Maybe you'll understand what I'm talking about in a second. Get your integral set up first.
Like, I have my integral set up. Okay, so let's do this. So, I hope I'm right, but I don't think I am. 24 pounds? Well, no, I can set up the integral alright. That's not hard.
Okay, so
I got my.
that's
400 squared?
yes, no.
Oh, man.
You're on the right track with the thing. So that's pretty ugly, although you could use sub 2 to the 2x, and that's fine, there's an easier way. What's a nice way to rewrite 2 to the x to the second?
So not 4x. That's not 4x.
What?
2 to the 2x.
Not 4,
Two to
I
the
think
two.
you're saying it 4x?
4
4 2dx. It is. This is the same as this, which is the same as this. And so, yeah, it is the same as 4 to the x. And that's easier to integrate and don't have to use some. So, pi 0 to 3 of 4 to the x. What's the antiderivative by virtue of today's lesson of 4 to the x? 4 to the x over log 4 when you divide, times log 4 when you differentiate. Today we're integrating, so it's divide. This is definitely a case of where 0 does not equal 0. When you put 0 in, it's not 0. Be careful. 4 to the 3 minus 4 to the 0 is a 1, so you're going to see that a lot here. Don't fall into that trap of thinking, oh, when 0 goes in, that's nothing. That's not the case here. So what do you get?
I don't know.
What's the middle? 4 cubed minus 4 to the 0.
63.
63 pi over.
I don't know how that's allowed. That doesn't seem like it should be allowed.
I go
2x squared does not seem like that should.
Of course it makes total sense to me. 2 to the x times itself,
Oh, so it's just.
which
Okay.
is 2 to that now. Actually, if you, that actually might lead you to think that you can multiply those together. Is that a thing?
No, you are.
2 to the 2x's, yeah, that doesn't help any. I still say yes, it's the same. 2 squared then x. I just don't understand. Why not? Why is it not a thing?
Well, it is a thing, I believe
Okay.
you, but like, it just doesn't feel right.
It's
It's
always
been
right.
too long since I've done that, so.
It's right. And then there's one more. Go!
Oh, kind of
Is this on your paper?
Yeah, it's on the back.
Okay. Before we're on to the last idea, which is unrelated.
Oh, no, like,
The goal is to give you practice on volumes and these integrals together.
hold your horses. I don't know how to draw a lot. I think I screwed it up because.
Is that left one or up one?
Left.
What's the base?
10.
10. That's called the common log. Base 10.
Yeah, that's.
That's good.
Yeah, but
Why?
there needs to be another. Oh, I did it on the other side. Got it. I thought it was on the other side.
It's
Watch your language. Yes.
Drawing confused me.
Trying to pour by Alex.
Got it. Not quite sure.
1 equals log 10 x plus 1. 10 equals x plus 1. No, it's 9, Michael. Integrals from 0 to 9. Oh,
So if it's around y, you use what variable? Y.
Yeah, no, I was doing the area. It says area.
Did I say calculator or no calculator? Calculators for the week. Let's do it without a calculator. So one. What is that squared?
No, that's not cool.
100y. Okay. You know what you can do when you're working out.
Because 10 squared is 100, right? So it would be technically 10 to the 2y.
No, but that's what we just totally did. We argued. It's 20y, right?
Okay, what is this?
4y.
4 to the y. Now, just so we're clear, what is this?
5 to the y. 6 to the y.
Okay, now you're all right. Okay, so actually, you say it's 6 to the y.
I say 5.
Let's verify. What's 2 squared times 3 squared? Is that 6 squared?
No,
it is not. Actually, is it?
4 times 9 is 36.
Emily, I meant 100.
It is. Okay,
Yeah.
right? Because it's like 2 times 3 itself squared, so it's all good. Now then, all I'm saying is be careful with rules of exponents. If I take 10 to the y times 10 to the y, what is it?
100 y.
It's either 10 to the y times itself, which is indeed 100 to the y. Maybe they just grown when you say it.
Minus
I don't know.
2
What's
20y?
minus
1 to the y?
minus 20 to the y or 2 10 to the y?
2 10 to the y.
2 10 to the y. Play it safe. Okay, plus 1. All right then, here we go. A lot of good practice here. What's the antiderivative of 100 to the y? What's the antiderivative of that boy? 2 times 10 to the y over natural log of 10 plus y from 0 to 1. And shall we proceed or should we call it good?
We call it good.
Ah, you sissies. All right, let's move on to the next idea. Okay, this was a portion on, I think it was yesterday's homework. Who asked about this? Was it you? I think you asked about this.
Yeah, it was me.
Is this on 71 or 2 or 3? Okay. So, this goes to a skill that I need to get you into your head for college. This is my college calc test, 1 through 3. So I gotta say, this common calc text will have a table of integrals at the back. Now this one is lacking in it. It only has 94. Okay, there are 94 antiderivative, and depending on if your professor's a total psycho Nazi or not, you might have to memorize up to 94 antiderivatives. That is ridiculous. Any professor worth their salt says, here, you can look it up, but you need to know how to apply it. Now, really, this then is practicing how to apply it. You know that these basic shells are arcsine of u and arctangent of u, yeah? Now, then the question is, all right, be able to adapt it to this problem and that problem based on a given livelihood. So that how to take a known rule and figure out what is applicable here, that's the hard part of today. So, first of all, if the 1 isn't there, then the first thing you should do is make the 1 there. So you could factor out a root 25. When you factor out a root 25, you're left with 1 minus x squared over 25 there. Are you cool? Okay, that then is going to go to ready to use sub. This is like the basic blueprint. You now need to figure out, all right, in this case, u squared is x squared over 25, which implies u is x over 5, which means du is 1/5 dx, and therefore 5 du is dx. Now, with all that done and thrown in there, then this problem becomes the 1 over root 25, I'm just going to call it a 1/5 out front. Cool? Now, the dx becomes
5 du.
5 du. The root becomes
1 minus u squared.
1 minus u squared. After that, anti-differentiate, the 5's drop, and it's just arcsine of u plus c, which is arcsine of, what is u? X squared over 25 or x over 5? X over 5 plus c. So if you do not get the 1, make the 1. Let's try another one. Actually, maybe you should try this one then. Do you get the point?
Kinda.
Okay, so for here, no root addition, we think arctangent. Make the 1. This is the 1 that I'm talking about, the constant 1. How do I make that 1? Divide a 7 out. Okay, when I divide a 7 out, then I have 3x squared over 7 plus 1. Do you agree? Okay, after that, identify the u squared. In this case, u squared is 3/7 x squared, which means u is square root of 3/7 x, which means du is
1 over 2.
square root of 3/7 dx.
Oh, I'm trying to go.
So the square root of 7/3 du is dx. You follow? Am I going too fast for you with me?
Oh,
Okay, sorry. Okay. So you make it, try and fit the blueprint by making the 1. After you make the 1, you decide what u squared is. Then you find all the corresponding details. So here we go. 1/7. Let's substitute. Dx is equivalent to root 7/3. You could definitely pull that up front, no problem. Over u squared plus 1. That then means what? 1/7 root 7/3 out front. The antiderivative is arctangent of, let's just save our trouble, and instead of saying u, let's sub back with arctangent of
3 over 7.
root 3 over 7 x. Okay? Plus c, yes. All right. Let's try worse. Okay? Oh, it gets much worse. Let's hang on. It gets way worse. Okay, here we go. If the perfect square isn't there, then you should make it. how do you make the perfect square?
Very good.
How do you complete the square? Okay. So you go with square root of. Okay. So let's go with negative out front of x squared plus 2x. Leave a space.
Whoa. Oh my goodness.
Oh, geez.
Okay. This problem right here is why I teach it that way. Now, some other school, you have terrible algebra skills, and I got to teach this calculus and teach you how to complete
Plus one.
square. You know how to complete square. I know you do.
Plus one. Plus one.
Plus one. Okay? Now, what did you really add there? Was it a plus one?
It was plus one square.
It's really a negative one, so balance with a positive one inside the root. Okay? So now when you go to write this as a perfect square, it should be right there. Thank you. 1 over, you got me. 1 over,
1 over negative.
let's write this in a arc-sine blueprint kind of way. So, what is it? Usually the constant comes first. So 1 minus the square of x plus 1. Okay. Now, we have the blueprint, we have the 1. Now we let u squared is x plus 1 quantity squared, so u is just x plus 1, so du is dx. We're all good there. That's nice and clean. When I make that substitution, I get 1 over root 1 minus u squared du straight up. So my antiderivative widths up that is
Inverse sine of x plus 1
inverse sine of x plus 1
plus c.
plus c. Okay? Okay. So, you try this one. You could do it. Actually, this is not the you tried, but you still, do you feel like you could do it, or should we do another one together?
We can do it.
That's fair. Give it a go. I'll
Sorry, guys.
trail behind you and pick you up when you stumble and fall on your face. I like unconscious. You start out on your face? That's terrible.
Yeah, I know how to complete the square.
Are you serious? I didn't notice.
That's, this kind of stinks if you're seeing it, because not only does it have it between the square, but also
Oh my
has
gosh,
the
look at the
non-one
7.
problem,
That
right?
is so not cool.
So how do you do with that non-one problem?
Take out a third.
Take out a third.
Third, I got a 7.
Did I make a mistake?
Plus 4 minus 4 cancel. Did they not? Oh no, because it's part of the.
Yeah, you used that to complete the
Oh,
square.
that's an AP.
All right, so. What?
Wait, it's X.
How are we doing?
So that means
Then you.
x squared equals x minus 2. Not root 3. Not root 3. Why would there be? Oh, for when you take the square root of it. I see what you're saying. I am.
And then du equals just dx.
1 over root 3
So 1
dx.
over root 3 dx.
So you kind of have to know yourself as far as skipping steps. Me, I would absolutely mess it up if I skip steps, so I don't. But if you mind to keep stuff straight without throwing everything, so be it.
I'm just hoping at this point that I can shape you up. What's up? Am I gonna?
How'd you do?
I'm good with your help.
Okay, after you are completely on your own. Go.
You have fun with that.
It just sounds so funny hearing you whack yourself.
It's so cold.
It's so
I think I have like a lot of spaces.
Yeah.
not easy.
Maybe in the
Again,
facetious?
Sydney.
Oh, man. Sorry about that.
It's like 1 over x.
Oh wait. Wait, ours is 11. Yours is a 1.
Oh my god.
You have an 11 here?
We totally have an 11.
Okay, that might be to avoid
I was
imaginary
like, I
issues.
don't know where that one. I was like, I didn't even.
So this is a positive 2 here then?
Yeah.
Yeah. It's fine. We got it, Emily. Don't worry about it.
Oh, that's this class. Sorry. Okay, nothing's new. Bye.
Wait, Sydney, did you get it? Sound like I got it right.
I said I got it right.